So to explain fragmentation, I'm going to use methylpropanoate for the example. So make sure you're familiar with esters. Here's the structure of methylpropanoate. So on our mass spec, we should find the peak at the furthest right should be at 88 m to z, as the molar mass of methylpropanoate is 88 grams per mole. Let's have a look now at how we could possibly fragment this molecule as it passes through the mass spec. First of all, we usually find fragments that have broken around the functional group. So let's try breaking it down here between the CH2 and the C double bond to O. We should get two peaks that correspond to these fragments, one at 29 m to z to correspond with the 29 grams per mole fragment, and another peak at 59 m to z corresponding with this fragment of 59 grams per mole. If we, however, fragmented methylpropanoate at this point between the CH3 and this through the C single bond to O, we'd get two different fragments. We'd get this fragment of 15 grams per mole, which should be represented by a peak at 15 m to z, and we'd get this fragment of 73 grams per mole, which should be represented by a peak at 73 m to z. There's another place we could likely find fragments, and this is right in the middle of this functional group split here. If we were to split the molecule at this point, we would get a fragment of 31 grams per mole, corresponding to a peak at 31 m to z, and also a peak of 57 grams per mole, corresponding to a peak at 57 m to z. Notice that for each of these examples, the two peaks would add up to 88, the overall molecular mass or the overall molecular ion peak. Also note that all of these peaks are possible. And also, we could have a situation where we do not find some of these, even though this is the answer. Sometimes fragments do not last very well in the mass spec and do not get detected very well, and sometimes there's not very much of them, so we wouldn't see the peaks at all. Let's look now at how the mass spectrum might look for these fragments. Here's a reminder of the original molecule, methylpropanoate. This is the molecular ion peak, 88 grams per mole. And the peak is at 88 m to z. This is the base peak, the highest peak on the spectrum, and you'll note that this peak is at 29 m to z, which corresponds to this fragment here of 29 grams per mole. This peak here is another high peak, and it is at 57 m to z, which corresponds to this fragment here, CH3, CH2, CO. Down the bottom here, we have a peak at 15 m to z. That's a really common peak. And this is from the fragment CH3, 15 grams per mole. Another peak that we can look at here is the peak at 59, and this corresponds to the following fragment. On the previous slide, we had a fragment of 73, but as you can see, there's no peak at 73. That's fine. This sometimes happens. And there's also a number of peaks on the spectrum that actually don't exist at all. And we don't have to explain every peak on our spectrum. That's the end of the fragmentation video.